Welcome to this detailed walkthrough of our project titled Nature-Based Prediction Model of BCU Reports. This system has been developed with the goal of assisting behavioral care units by offering intelligent, real-time predictions about the nature and severity of reports they handle. By integrating machine learning with a user-friendly web interface, our model aims to provide accurate insights based on historical data and new user inputs, thus improving decision-making and resource planning in sensitive healthcare environments. Let's start with how the project is set up and initialized. Step 1. We begin by opening the XAMPP control panel, a local server environment that supports PHP and MySQL-based web applications. In this step, we enable the Apache and MySQL modules. Apache is responsible for serving our website, while MySQL manages the database where input records and prediction results are stored. Without this, our local project environment would not function, so this is a critical initial step to host and run the model offline. Step 2. Once the modules are running, we open our browser and are automatically redirected to a PHP-based web page. This is the home screen or dashboard of our application, which is hosted locally through the localhost server. PHP acts as the core scripting language behind this page, handling dynamic inputs, server-side logic, and database connectivity. Step 3. Next, we navigate to the location of our project folder, which resides inside the htdocs directory within the XAMPP installation path. Running the project from this folder triggers our application, which brings up the main user interface. This UI is designed for easy interaction, allowing users to enter various types of data relevant to the BCU reports. Step 4. Once inside the application, the user is presented with a form-like interface. Here, they input a series of parameters that relate to the behavioral and environmental conditions being monitored. These can include things like patient activity, environmental factors, time of day, behavioral history, and any additional triggers that might have been observed. Each of these inputs plays a significant role in determining the nature of a BCU report, and our model relies on these variables to predict the outcome accurately. Step 5. After the data is entered and submitted, it is passed to the back-end system, where our machine learning model processes the inputs. This model has been previously trained using a labeled data set of past BCU reports, which allowed it to learn patterns and associations between various conditions and the resulting type or severity of behavioral incidents. The algorithm used might include logistic regression, decision trees, random forest, or any other classification model based on accuracy metrics evaluated during the training phase. Step 6. Once the model processes the inputs, it generates a prediction. This prediction is essentially a classification output, indicating the likely nature of the BCU report, such as mild, moderate, or severe. Along with the label, the model also provides confidence scores or probabilities that reflect how sure it is about the classification. This is valuable for the user to assess the reliability of the output and decide further actions accordingly. Step 7. The predicted outcome is then displayed on the screen in a visually intuitive format. Alongside the result, we provide supporting information such as graphs, pie charts, or bar plots that highlight the data used, feature importance, and outcome distribution. This makes it easier for users, especially those without a technical background, to understand the basis of the prediction. Step 8. All of the user inputs, along with the generated output and system timestamps, are then stored securely in a MySQL database. This ensures that data from every session is preserved, allowing administrators or researchers to track predictions over time, identify trends, and even retrain the model later using real-world inputs for improved performance. This historical database is particularly useful for healthcare professionals to reference past predictions, audit the model's accuracy, and ensure transparency. What makes our project impactful is the integration of artificial intelligence with behavioral care data. Typically, BCU reports are generated manually and depend on the subjective assessment of healthcare workers. This can sometimes lead to inconsistency or delay